Hi calculus students. This set of video notes is on curve sketching. So this is kind of seeing how we start with an equation of a function or certain information about a function, how we can then sketch, get some idea of what the actual function looks like kind of by putting together the first and second derivative tests. So the first thing we're going to do here, I've already kind of written out some stuff to kind of save us some time, is we're going to start visualizing curves based on information about the first and second derivative. So we're going to I'm going to give you a moment to kind of pause this video and see if you can complete A, B, C, and D. But the idea is you're sketching a curve that meets the requirements given here. So it's saying, okay, if f prime is greater than 0 and f double prime is less than 0, what does the graph look like? So I'd like you to pause the video and do that for these four. Then press play, and I'm going to run through what they should look like so you can kind of check your answers. All right, so at this point in time, I'm going to start going over the answers. So if you haven't already paused the video and completed it, you should do that. Okay, so each of these statements here is kind of corresponding to something I should expect to see in the graph of the function. So the first derivative being positive, I know that means that the function is increasing. And then the second derivative being negative, I know that means it's concave down. So what I'm going to sketch is something increasing and concave down. Needs to be something like that. Okay, for the next one, now f prime is less than 0, so I know my function should be decreasing. F double prime is still less than 0, so still concave down. So this is kind of like the other half of this curve, right? If I were to continue and curve it down, it should look decreasing and concave down. Moving right along, the next one says f prime is greater than 0, so that means increasing. And now f double prime is greater than 0, so I have concave up. So we should draw something like that. And my last one is decreasing and concave up. So that should look something like that. So if your graphs were not quite equivalent to these, make sure you have corrected them. I actually have two more graphs for you to try. Just didn't fit on our screen yet. But in these ones, so this one is saying f prime of c equals 0, which means like let's choose some x value to be c, and let's make that at that x value the first derivative 0, but f double prime is less than 0 everywhere. Okay, and same idea here. I pick some c value. So again, pause the video, try to sketch a curve, press play in a moment. Press play when you're done, and I'm going to go over some answers. So the idea here is if f double prime is less than 0, I know that means concave down. And then if I need the first derivative to be 0 at this x value as c, so that means I need to have a horizontal tangent at some point here. So the idea is like if it's concave down and I have a place where like there's a horizontal tangent, it must look something like that, right? Otherwise, it's not going to be. I have to curve it so it's concave down, but also make the peak being at c. So that's telling us, oh, this is going to be. That means this is a minimum. Oh, sorry, a maximum. Okay, and similarly for the next one, now it's concave up everywhere, and then c is still need to have a horizontal tangent. So now it should look something like that, where now c is a minimum. Okay, so I want to make sure we keep all these different shapes in our heads because we're going to start kind of looking at pairs of information and drawing like what should I be drawing on my function graph. Okay, so before we get into any examples, I'm just going to quickly run down what are our steps in curve sketching. And we're going to kind of refer back to these. So my first step is going to be to find f prime and f double prime. And I'm going to kind of make a little note about this step is sometimes we're not going to do this step because sometimes we'll be given information about f and f prime and that will be all we'll use. So we'll say sometimes given key info. So we'll skip this step. Okay, so then after we've identified our first and our second derivatives, because the idea is like those are what's going to give us all of our information to consider, like our maxes, our mins, our points of inflection, our concavity, intervals of concavity. And so I need my first and my second derivative. My next step is going to be to kind of do the derivative tests. So we're going to say create a number line for f prime and f double prime. And we've been doing those number lines separately because we've been doing the tests separately. But I'm going to look at here is like how can we kind of put all the information into one number line and look at information about f prime and f double prime all at the same time. But our kind of like annotation here is going to say do the derivative tests. Because this is going to give us all the information I'm going to have to put together into a graph. So my next step would then be, now I kind of like know my maxes, my mins, my increasing, decreasing concavity. So now I kind of want to start to actually graph. And the thing we're going to graph first will be the key points. So we'll say plot key points. And what I mean by key points are going to be maxes and mins. And points of inflection. And sometimes we'll have endpoints. And sometimes you'll have intercepts, like x and y intercepts, or it might be easy to find these. So we'll say if known. And then our last step is going to be, once you kind of have those key points mapped out, connecting the dots. So connect to those points. And the way in which we connect the dots is going to be important because we're going to have to think about our concavity, increasing, decreasing intervals. So you want to refer to your number lines for the shape of the curve. Okay, and now we kind of, so the first two steps in this process are things we've done before. These last two steps are what's going to feel a little new. It might also feel new to kind of do both derivative tests at once. So let's look at some examples now. So I've already written out the first example to kind of, again, save me some time. But this is an example in which you're given a table of information. So it says sketch a graph of f of x given that f is continuous and we know all of this. Okay, so we dealt with a table like this in class, and so for some people it was a little challenging to kind of decipher that table. But we're going to kind of see, and we're going to kind of see how we can turn this into a number line. But if I'm kind of running through my steps, my first step would be to find the first and second derivative. But because I already have this chart, I don't need to find my f prime and f double prime because I already have the information I need about f prime and f double prime. So we'll say given key info, skip step 1. Okay, so now I can move on to step 2, which is to create my number line. And I see like there's 2 critical points on here at 5 and 8. One thing I noticed is like 5 is actually only a critical point for f prime, not f double prime. F double prime isn't 0, does not exist at there, but I'm still going to kind of put it all together into one chart. At 8, however, both the first and the second derivative doesn't exist, so that means that actually is a critical point in both derivatives. But let's see what happens when we create this number line. So I'm going to put 5 and 8 and kind of draw my dotted lines. And then I'm going to start with f double prime on the bottom. Then I'm going to do f prime right above it. And lastly, I'll do f. So I'm going to actually have something for all 3. So what I put here in between is going to be actually the signs that I see in the chart. So I see, okay, x less than 5, I know f double prime is negative and f prime is positive. At 5, I know that f prime is 0, right? F double prime is still negative, so I could even put a little negative there. Between 5 and 8, they're both negative. At 8, they both don't exist. So I could, if it helps you to write in the d&es, you can write them in. And then now my first derivative is positive, my second derivative is negative. So after I do that, what I sketch up here for f is going to be one of the 4 shapes that we did at the beginning of these notes. I'm going to show that again for a moment. Like, I'm kind of comboing a plus and a minus to decide if it should be increasing concave down, increasing concave up, decreasing concave down, or decreasing concave up. And so I should be able to sketch one of those 4 shapes on each of the intervals here. So like for this one, I'd say, oh, it's increasing because f prime is positive, and it's concave down because f double prime is negative. Must look like that, right? From 5 to 8, they're both negative, so it's decreasing concave down, looks like that. My last one, it's again increasing concave up. Okay, so if I kind of look here, if I imagine connecting each of these pieces, that's going to give me a rough idea of what the shape of my graph looks like. I can also start to draw conclusions about what exactly is happening at 5 and 8. So at 5, since f prime goes from positive to negative, I know this is a max. And then at 8, I see nothing. My second derivative isn't changing, right? But my first derivative is changing. It's changing from negative to positive, so I know that's a min. Okay, so that's step 2. Now I'm ready to kind of put it all together in step 3 and start actually graphing. So when I go to graph, I first of all need to think about what part of the coordinate plane I want to show. And since I have critical points at 5 and 8, I really don't need the negative x-axis at all. I really just need to make sure I have 5 and 8 on here. And since I know, now I'm going to plot a point at 5 and 8. And it doesn't really matter what height I have them, except that since 5 is a maximum and 4 is a minimum, I'm going to decide to put 5 higher and 8 lower. So maybe there. Okay, and if you could have put either of these in down here too, it doesn't matter. So now that I have I know that's a max, I know this is a min. Now I'm going to kind of draw in the shapes of the curves. So now this was step 3 was just plotting the points, and now step 4 is going to be to actually sketch the parts in between. So I see I'm going to sketch like this to the left of 5, so that looks like that. Then I need to connect the point here and here with this shaped curve, right? So something like that. And then at this point, it's now going away from 8, looking like this. And if we think about it, like, it makes sense that I have a cusp here, because here I had my first derivative not existing, so it's not differentiable there. So that confirms why the derivative says d/e. Okay, let's look at one more example. So in this example, I'm going to start by saying we have the first derivative. So let f prime of x equal 4x to the third minus 12x squared. And we'll say sketch a possible graph of f. Okay, well, if I'm running through my steps, my first step is to find the first and second derivative. I already have f prime, right? We were given f prime, so f prime of x is this 4x to the third minus 12x squared. I can find f double prime by taking the derivative of f prime, and I get 12x squared minus 12x. Now I want to do step 2, which is to create the number line. But in order to first create my number line, I need to find my critical points here. So I'm going to set each of the derivatives equal to 0 and see what my critical points are. So if I factor out a 4x squared, left with x minus 3 here, and I get critical points at 0 and 3. And for my second derivative, oh, I made a mistake here, by the way. This, when I should have brought down this 2, sorry. This would be a 24. Okay, so 24x. So now that this is the correct second derivative, I can factor out a 12x, left with x minus 2. So I have 0 and 2. Now, I'm going to put all these critical points on the same number line, but one thing I noticed is that 0 is a critical point for both, 3 is only a critical point for f prime, and 2 is only a critical point for f double prime. So I'm going to kind of have to keep that in mind as I go to sketch my number line. So I'm putting, the key things are 0, 2, and 3. I'm writing f double prime, f prime, and f. And so when I do my sign analysis, I need to kind of be plugging back in. So I'm going to kind of highlight, for f double prime, I really only need to check 0 between, like, check the sign change at 0 and the sign change at 2. Anything after 2 is all going to be the same sign, so I don't really need to check on either side of 3. So if it's less than 0, then I have something like I plug in -1, that's negative times negative, so I get positive. If I plug in 1, I get positive, negative, so it's negative. If I plug in like 2.5, positive, positive. Oh, and actually I could have plugged in 3 even, I realized. I just told you it doesn't matter. But anyways, anything after 2 I could have plugged in, and that means everything here is positive. So I can also put a plus sign over here without actually checking. Okay, now let's do f prime. So if I plug in -1, positive, negative, so it's going to be negative. If I plug in 1, positive, negative, so it's still negative. Oh, I forgot to tell you, like, which places do we care about for f prime? So, like, I care about 0. I don't actually care about 2. I care about 3. So I'm kind of like highlighting the places I'm going to definitely need to check, which means, like, in between 2 and 3, if I got negative when I plugged in 1, it's still negative here. And then after 3, if I plug in 4, that's now positive, and that's positive. So putting this all together, we see decreasing concave up. So it should look like that. Then decreasing concave down. So now it should look like that. Here it's decreasing concave up again. And then increasing concave up. So it should look like this. So now I'd like to kind of think about what's going on at 0. Well, at 0, there's no sign change in my first derivative, but there is a sign change in my second derivative. Must be a point of inflection. At 2, there's another sign change in my second derivative. Must be another point of inflection. And then at 3, there's a sign change in my first derivative from negative to positive. Must be a minimum. Okay, so now let's put this all together, see what our graph looks like. So I'm labeling 0. Oh, I don't know why I put 0 right there. That's 0, sorry. Let's call this 1, 2, and 3. Okay. So now what I'm going to do is try to plot these points. So I know I should have a point at 0. And that's going to be a point of inflection. I'm going to it's going to be coming down from there, so I don't want to put it too high. So maybe that's the POI. And then at nothing going on at 1. At 2, there's another point of inflection, and I was decreasing right before that, so I better kind of have it lower than this one. Maybe it's over here. That's another point of inflection. And then at 3, I should have a minimum. Again, I was decreasing between 2 and 3, so I'm going to make this one lower. And, sorry, one sec. Okay, so then, now I need to, so that's step 3, what I just did. This is like step 3/4. Okay, and let's call this a min. Now I need to sketch in between those points. Okay, so this might feel like the hardest part, but I'm really just looking here as a cheat sheet. So it's like to the left of this point of inflection, I should draw a shape like that. There we go. Then, but connecting these two dots, I need to draw this curve. So I should draw it like that. And again, this is now a point of inflection where I switched from concave up to concave down. Now at this point is another point of inflection. Now I'm drawing this shaped curve to get down to my minimum. And then lastly, I'm curving up at the end. And there we go. We've now sketched a potential graph for the original function, all based on just knowing the derivative from the beginning. So I recognize this is a somewhat long process. We're definitely going to be practicing this process. And I'm going to leave you with one U-try problem. And I would say if you're totally feeling mind-boggled right now, at the very least for your U-try, you should be able to do steps 1 and 2 and then see how you can do with the final steps 3 and 4 of actually sketching. But at the very least, you should be able to kind of put together the first and the second derivative tests and see if you can do a number line. And I'm giving you a polynomial. And we have f of x is x to the third minus 6x squared plus 9x plus 1. And the idea is, so you'd have to, we didn't do one where I started with an original function, but you'd have to take the first derivative, then take the second derivative, then do both derivative tests and put it all together. So best of luck there, and we will be practicing next class.